Hi, in this video, we are solving the question number 1. That is the numerical 1 from the exercise for the chapter Laws of Motion, which is the fourth chapter in the 11th standard physics. Now, in this question, हमें एक situation दी गई है which involves a truck and initially ये truck जो है एक uniform speed के साथ travel कर रहा है along a horizontal road. But then story में twist आता है and this truck stops suddenly. Why? Because truck का engine fail हो जाता है apparently. And based on this particular given scenario, we are expected to calculate the frictional force acting on this truck. Now हमें पता है कि real life में whenever an object is moving, such as a truck, a resistive force such as friction will constantly act upon that particular moving object. And that is what we are supposed to calculate. But we are not supposed to just calculate that. We are supposed to find the comparison between the frictional force acting on the truck and the weight of the truck. So basically एक ratio पूछा है हमसे. एंड देन इस क्वेश्चन का सेकंड हाफ भी है वेयर दे से कि ये स्टोरी जो है वो रिपीट होती है बट नाउ फॉर अ कार विच हैज अ मच लेसर वेट दैन द ट्रक एंड दे आर आस्किंग कि इस केस में जो कार पे लगने वाला फ्रिक्शन होगा एंड कार का जो वेट होगा उसका रेशियो क्या होगा. विल इट बी सेम एज द ट्रक, विल इट डिफर? We don't know yet, so let's get into it. So this was the initial grasp of the particular question. Let's dive a little bit deeper. So सबसे पहले what we'll do is कि इस situation का हम एक free body diagram that is FBD बनाएंगे. So let us get the FBD on our screen. So as you can see, ये एक generic FBD है where we have considered system as a vehicle. Now this vehicle can be a truck or a car. At this point it does not matter for us. Now क्या करेंगे, इस सिस्टम पर लगने वाले सारे फोर्सेस को रिजॉल्व कर लेंगे. So सबसे जो अपेरेंट फोर्स है जो हमें बाय डिफॉल्ट पता है, दैट इज द फोर्स एक्टिंग इन द डायरेक्टली डाउनवर्ड डायरेक्शन, दैट इज द फोर्स ड्यू टू अर्थ्स ग्रेविटेशनल फील्ड एंड इसको हम रिप्रेजेंट करते हैं यूजिंग वेट. ठीक है. नाउ हमारा जो व्हीकल है इट मूव्स इन दिस डायरेक्शन, सो नेचुरली इसका रेजिस्टिव फोर्स फ्रिक्शन विल एक्ट इन द ऑपोजिट डायरेक्शन. सो हमने वो फ्रिक्शन को भी लिख दिया. ना इस व्हीकल को जो डायरेक्शन में मूव कराने वाला फोर्स था दैट हैज फेल्ड नाउ एज द इंजन हैज फेल्ड, सो इट हैज नो फोर्स इन दैट डायरेक्शन. So whatever acceleration with which the truck will stop has to be a result of our friction. Okay, so it has to be in the same direction as the friction. So this is our free body diagram based on which we have to calculate frictional force. Now यहाँ पर क्या है, in this particular situation we know the value of weight, it's given to us. We don't know the value of friction, but that's what we are required to find out. But we don't know the value of A also yet. So what we need to do is we need to figure out a way to calculate A, because only then we can find F. So forget about laws of motion. According to the situation, if we see situation कुछ ऐसी दिख रही है जहाँ पर हमारा vehicle था, it was traveling at some initial velocity, it travels some distance and then comes to rest. Now this kind of looks like a motion in a straight line. And हमने इसके बहुत सारे formulas देखे थे using all these values we can find A. And that's what we are going to do. We're going to calculate A and then use it over here to calculate our frictional force finally. So now that we understand the flow of the numerical, let's get into the solving side of it. So सबसे पहले हम देखेंगे the given data. And yep, इतना सारा given data है in this question. ये हमने सारा का सारा data जो है question से extract किया है. But before I explain what data we have, all the quantities जिसका भी subscript 1 है, that represents the quantities for case 1, which is truck, and all the quantities जिसका subscript 2 है, that represents the quantity for car, which is our case 2. So दोनों ही cases के लिए हमें जो बताया गया है कि our vehicle was moving at a constant initial speed. This speed is given as 36 kilometers per hour. But for this particular question, we have no use for this kilometer per hour ka value. We need to convert it into the SI unit, that is meter per second. I hope you know the trick, that is 36 into 5 by 18 gives us the velocity in meters per second. Now the second set of values जो हमें पता है, that is the individual masses of each vehicle. So M1 is the mass of truck, which is given to as 5 ton, which in kg becomes 5,000. Similarly, M2 is the mass of car, which is given to as 1 ton, which in kg becomes 1,000 kgs as well. Now the distance traveled by both the vehicle is same in this situation. Okay, both the vehicles are traveling the same situation, which is 1 kilometer, which in SI is 1,000 meters. Now for the fifth value, that is for the final speeds of both the vehicles, there is no value given to us in the question. But these are the sort of values which we infer from the situation. सो सिचुएशन क्या है कि इवेंचुअली दोनों व्हीकल स्टॉप होने वाले हैं, so their final speed has to be 0. Okay, so now that we have written all our given data, let's get into the to find section of our numerical. So what do we have to find? Well, as I said, we need to find friction, but moreover we need to find the ratio between friction and weight. Okay, so it's a ratio of two forces, that's what we are required to find. Okay, so now that we are clear कि हमें क्या ढूंढना है, let's try to find it for our case one, which is the case for our truck. So जैसे कि आप देख सकते हो, हमने ट्रक के सेक्शन में ट्रक का FBD बना दिया है, which is similar to our previous FBD, but सारे जो forces और components है, it is with respect to truck. So this is the weight of the truck, this will be the frictional force acting on the truck, and this is the acceleration with which the truck will eventually stop. So now based on this FBD, we can construct an equation using the Newton's laws of motion. Since इस horizontal direction में, इस axis में सिर्फ एक ही फोर्स है जो ट्रक पर एक्ट कर रहा होगा, सो हॉरिजॉन्टल एक्सिस के लिए रिस्पॉन्सिबल भी ये एक ही फोर्स होगा, एंड दिस इज व्हाट वी रिप्रेजेंटेड using mathematics. So at this point we know the mass of the truck, we are required to calculate friction. Acceleration of the truck on the other hand is unknown to us, so first we need to calculate this acceleration and then only we can find our desired quantity. So let this be equation 1, and let's move on to calculate the value of acceleration using the equations of straight line motion. हमने ये equations last chapter में पढ़े हैं. This is the third equation of kinematics, and all the values except for the acceleration is given to us. So let us quickly substitute all those values. So our equation becomes something like this, and then if I were to rearrange all the unknown quantities on one side and all the known quantities on the other side, हमारा equation कुछ ऐसे बन जाएगा. So a1 is equal to minus 100 by 2000, and if we were to further solve this, हमें a1 की वैल्यू मिल जाएगी, which is minus 0.05 meter per second square. Units are very very important. Now let this be our equation 2, because what we'll do is हम इस equation से a1 की वैल्यू इस first equation में substitute करेंगे to get our frictional force. So let's do that. So if we substitute, I can say from equation 1 and 2, frictional force on truck is mass of truck into acceleration of truck, which comes out to be minus 250. Now, as I said, end goal is not to find this. End goal is to find a ratio. So at this point, मैं सिर्फ इसके magnitude में interested हूँ. So if I were to calculate the magnitude of our frictional force, it would be just 250 newtons. Now let us quickly substitute this into the formula for ratio. So the ratio is frictional force upon the weight of the truck. फ्रिक्शनल फोर्स हमने यहाँ से ढूंढा है. वेट ऑफ द ट्रक इज वेरी इजी, इट इज मास ऑफ द ट्रक इनटू एक्सेलरेशन ड्यू टू ग्रेविटी. वी आर यूजिंग द वैल्यू 10 फॉर सिंप्लिसिटी ऑफ कैलकुलेशन. सो हमारा इक्वेशन जो रेशियो आएगा दैट इज 1:200. सो दिस इज द वैल्यू फॉर आवर रेशियो ऑफ फ्रिक्शन एंड वेट फॉर ट्रक. Similarly, let us quickly calculate this value for our second case, that is for our car. So अगर हम कार का इक्वेशन देखेंगे तो we have a similar FBD, but अब सारे components है are with respect to car. This is the frictional force acting on car. This is the weight of car, and this is the acceleration with which the car will stop. So similarly, we get an equation using the Newton's laws of motion from this FBD. That is, this force is responsible for this acceleration. So as per laws, this must be the equation. Again, this is unknown, so we need to calculate this first. So सबसे पहले let us use the equations of straight line motion. Similarly, सारे quantities given है except for acceleration. So quickly substituting all the values, we get something like this. Rearranging the equations, I get an initial equation for my acceleration. Upon solving, I get the final value of the acceleration. One thing you must have seen कि दोनों acceleration की value same है, which is a good thing. So second thing, also one more thing I forgot to mention is, like, it's a good thing that this acceleration came out to be negative, because as we see, all these accelerations are the acceleration of retardation or deceleration. They are stopping the vehicle. So this acceleration has to be negative. If ये minus sign आया, मतलब हमने calculation में कोई mistake नहीं की. So it's quite reassuring. Okay, so moving on. we use this value of acceleration into this equation to calculate our friction force, which in this case comes out to be minus 50. Again, I'm only interested in the magnitude of this force, so my magnitude of frictional force acting on car is 50 newtons. Quickly finding the ratio, so frictional force acting on car divided by the weight of the car. Frictional force ka value is 50, weight of the car is mass of the car, that's m2 into g. And if I were to calculate the ratio, voila, what do you know, it's same. So दोनों ही केस में हमारा जो रेशियो है that is between friction and weight of particular vehicle is same. So I can make this statement pretty comfortably कि friction is 1 by 200 times of weight in both the cases. With this, I hope this helped you. अगर आपको इस particular solution का PDF चाहिए, so you can check out the description box. इसका PDF description में available है. Thank you.